Texas early voting ends this Friday. If you're registered to vote in Travis County, you can early vote on campus at the FAC. VoteTravis.com has a full list of Austin area early voting locations. You can search all Texas early voting locations at votetexas.gov. In Texas, you must show a government-issued photo ID like a Texas driver's license or U.S. passport to vote. You can early vote between 7 a.m. and 7 p.m. Time to early vote, Longhorns.
Live from the University of Texas at Austin, the Liberal Arts Development Studios present Essentials of AI for Life and Society. And now, here are your professors, Joydeep Biswas, Don Fazell, and Peter Stone.
Hello, and welcome to week 11 of the Essentials of AI course. I'm Don Fazell, the chair of the Computer Science Department, and today we have with us Professor Craig Watkins of the School of Journalism and Media and the Moody School of Communications here at UT, and he's also the director of the IC² Institute. His research is in many aspects of the social implications of AI and computer-mediated technologies with a focus on equity issues. He's a principal investigator for the Good Systems Grand Challenge here at UT, which, as you may well already know, is a multidisciplinary initiative supporting exploration of the technical, social, and ethical implications of AI and computing systems in general. And he's an internationally recognized expert on today's topic, which is bias and fairness in AI models and ethical data sets. And so without further ado, Craig, please take the floor.
Great. Thank you, Dan, for that introduction, and thank you, Good Systems, for offering this course to our campus community, and I'm excited to be here today. As is noted, I'll talk a bit today about some research that I've been doing, but also cover a fairly broad terrain of research that's beginning to unearth a lot of interesting challenges that are associated with the proliferation and widespread use of artificial intelligence models in our society and certainly around the world. Just a little bit of quick background. I'm a social scientist by training, professor in the Moody College of Communication, also director of the IC² Institute, where we are beginning to do more and more work in the intersection of AI, society, and health innovation specifically. And as was mentioned, I'm also one of the principal investigators for the Good Systems Grand Challenge. So today's talk is really built around three core questions, and I'll walk you through each of these questions throughout the course of this particular talk today. So question one is, how are bias and systemic inequities expressed in artificial intelligence? And I snuck in a fourth question there, and why should we care as a society? One of the catalysts for the Grand Systems Grand Challenge was the recognition that these systems were beginning to have wider and wider impact and potential for impact, and the need to mobilize greater resources to understand the consequences and the impacts of these developments. The second question is, what factors contribute to bias and systemic inequities in artificial intelligence? These systems don't just fall out of the sky, they don't just generate themselves, but in fact are generated by a series of human practices and expertise. And so we want to delve into that a bit as well to understand, what are some of the underlying factors that contribute to some of the systemic inequities that are oftentimes expressed in artificial intelligence systems. And then finally, the third question is, what kinds of techniques are being developed to mitigate bias and systemic inequities in artificial intelligence? Indeed, an entire new industry has emerged, both within academia and beyond, to address some of the challenges that I'll share with you here today. So let's get started. Question one, how are bias and systemic inequities expressed in artificial intelligence, and why should we as a society care? I want to give you just maybe three or so examples of the ways in which researchers have unearthed the manner in which systemic inequities have found themselves being articulated and demonstrated through various kinds of artificial intelligence systems. Some of you may be familiar with the use of artificial intelligence as a risk assessment tool to sort of try and understand or to predict whether or not a defendant might commit another crime or offense. ProPublica, back I think in 2015, released a really interesting investigative report looking at Compass, which was a widely used risk prediction algorithm that was being used by a growing number of judges around the country and began to discover some really disturbing results, which have been verified via other kinds of academic studies as well. And that is the extent to which the models, again, which are designed to try to predict whether or not an offender will recommit a crime. Results were such that, for example, black defendants were oftentimes assigned a higher risk score, even though they may have had the same or similar criminal record as their white counterparts, were oftentimes being deemed by the sort of rank ordering mechanism as much more dangerous and much more likely to commit crimes in ways that weren't really consistent with what we have come to understand was actually the case. African Americans are much more likely to be higher rates of false positive. Contrast to that, higher rates of false negatives for white defendants, identifying them as unlikely to commit a crime or an offense when in fact they were likely to commit a crime or an offense. And so the sort of main takeaway here is the ways in which this particular algorithm were being used to deliver a pretty high stakes kind of output, trying to, again, predict whether or not someone would commit crime and what that might mean in terms of a sentencing, practice or protocol. And what I think researchers have come to understand and take away from that in other kinds of studies, and we'll come back to this later, is that what was intended to be a sort of a crime predictor algorithm was in fact a predictor of who was most likely to be arrested, a very different outcome. A few years ago, Amazon sort of internally sort of experimented with a recruitment tool, an AI technology that would allow it to sort of identify prospective candidates for jobs that it was attempting to fill, and like a number of other companies began to automate this process. But soon as the process was underway and after outputs and feedback began coming from the system, Amazon and some of the external evaluators of the system began to recognize something strange. And that is that the system was much more likely to reject or to demonstrate bias against female applicants for these positions, and at such a rate and to such a degree that Amazon decided to sort of basically scrap the entire project, the whole experiment, recognizing, right, that it simply was performing in a manner, right, that it simply could not justify. And we'll talk a bit about kind of what were some of the underlying factors and conditions that contributed to this particular output, but the main point here is just to give you some examples of use cases or real world instances where AI has basically gone wrong, gone bad, and as a result demonstrated, right, certain kinds of biases and discriminatory or disparate impacts that have affected certain segments of the population. Many of you are probably familiar with the facial recognition technology and the degree to which this is increasingly sort of expanding both in this country and certainly around the world. What researchers have sort of discovered as it relates to this particular technology, right, is the higher rate of false match for African Americans, particularly African American women and their black male counterparts. In this graphic here, what you'll see is as you move along this continuum, basically rating the degree to which black men, black women, and white women are matched at levels or in ways that are comparable to how white men are matched. And what you'll see here as you move further down the lower axis here is the sort of high rate at which African American women in particular were being falsely matched via a facial recognition system, suggesting again and really sort of catalyzing an entire movement, right, to convince a lot of technology companies, police departments, et cetera, to suspend use of this particular technology simply because it was not reliable and simply because it was reproducing match error rates that simply could not be justified. And in terms of the impact of these kinds of systems, about 3 years ago, the New York Times reported, right, the first instance of someone being wrongly accused by an algorithm, sort of a matching error as a result of this facial recognition system. And it began to sort of catalyze an even stronger call, right, to suspend use of these systems, particularly in this kind of context, simply because they were not reliable. About 2 or 3 months ago, the New York Times and other outlets reported a similar kind of instance where an African-American woman, 8 months pregnant, was arrested because she was falsely matched via a facial recognition system for committing a burglary. When the officers came to her house and she showed them her condition, 8 months pregnant, they still arrested her and of course causing a huge outcry. But again, the point being here, right, is that these systems, once they get out into the real world, without proper regulation, without proper guardrails, can sort of demonstrate systemic biases and inequities that are sort of in some ways replicating those same kinds of biases, sort of pre-AI era, if you will. Obviously, right, a lot of attention in terms of artificial intelligence has been generated with the rise of ChatGPT. So as of November of last year, just the number of people who have experimented with this tool it's been quite massive, both in this country and certainly around the world, enabling OpenAI to essentially amass a market share and evaluation that is quite extraordinary in terms of how this particular system has propelled it, right, to greater heights, greater publicity, and sort of worldwide recognition. What we know is that these systems have been adopted by a variety of people in the education sector, in various other kinds of sectors, creative industries, creative arts, for example. But what I thought was really interesting, right, is doctors too began to start experimenting with ChatGPT and other similar kinds of large language model technologies. And so one of the questions that we have to ask ourselves, right, is sort of what are some of the risks? We certainly understand the potential benefits of large language models, the ability, right, to get feedback, the ability to sort of generate outputs that can serve a particular task or performance in a very efficient and, if correct, in a very effective way as well. But what happens, right, when these models are deployed, particularly in high stakes scenarios or high stakes situations, and they don't perform reliably or they don't perform well? This is a study that was published about a year or so ago. A group of researchers were essentially interested in understanding if they substituted human expertise for machine expertise, in this case GPT-4, and presented it, right, with different vignettes, clinical vignettes or patient presenting with certain kinds of conditions, certain kinds of symptoms, how might the machine learning algorithm respond to and generate an output that might be useful in a clinical context. So in this sense, right, it was an attempt to sort of assess to what degree this model might perform in a way that was both reliable, trustworthy, but also able to sort of mitigate, right, potential harms and biases. And in particular, right, what the researchers were interested in is, let's say it presented the machine with a particular vignette, a particular circumstance or a clinical situation. And what it would do is keep all of the conditions the same, but it might tweak or refine, for example, the gender, man or woman. Or it might tweak the race or ethnicity, white, I think, Asian, and Latinx. And then just by simply modifying the prompt in that way, the vignette in that way, the sort of goal of the study was to sort of determine, would the outputs be different? Would the model make specific recommendations, or would the recommendations vary depending upon how those demographic features were inserted into the prompt? And what it found, right, was really interesting, right, that by changing the gender and race or ethnicity significantly affected the model's ability to correctly prioritize diagnoses in a number of the cases, suggesting, right, that the model was sensitive to these sort of gender or demographic kinds of tweaks and refinements in the sort of prompting engineering that was taking place here. Similarly, right, it found that GPT-4 was significantly less likely to recommend advanced imaging for African-American patients when compared to their Caucasian counterparts. And again, right, the point to keep in mind here is that the conditions were the same, right? What they were presenting with in terms of symptoms, what chronic disease was being sort of assessed here. The only thing changing, right, was the race, ethnicity, and or gender of the sort of imagined patient or vignette. And again here suggesting, right, that the model was sensitive to those kinds of demographic attributes or features in a notable or significant way. And then finally, what they sort of conclude is that when there are known genetic and or biological relationships between a disease and a patient's demographics, the model tended to exaggerate those prevalence differences while generating clinical vignettes. We've heard a lot over the last several months or so with the rise and popularization of ChatGPT, with the tendency of these systems to what's called hallucinate, right? Just to make up information or to make up content. May look good, may sound good, may be grammatically correct, may be coherent, but is utterly false and made up. What studies like this are beginning to suggest, and a subsequent study that I'm going to share with you here in a moment, are beginning to suggest that the systems not only hallucinate, but they can exaggerate, right, certain ground truths, right, sort of going to the extreme, if you will, in terms of what might be a reasonable or potential outcome, but magnifying or expressing it in ways that are distorted and in some ways might lead to sort of disparate impacts. Now, the significance here, right, with some of these examples that I've given you here, is the degree to which, in this particular instance, how a large language model might impact or influence the sort of clinical decision-making process. Withholding, right, a recommendation for a particular kind of treatment or intervention or therapeutic solution, obviously, right, has significant consequences for the health and well-being of populations at stake here. And so one of the things that the researchers here suggest, and other researchers suggest as well, is the need to be quite cautious, the need to have established protocols and guardrails that protect against the ways in which these systems might lead to biased kinds of outcomes and biased kinds of human decision-making processes. With the arrival of ChatGPT, and most people were exposed to ChatGPT primarily via sort of text-based prompting and receiving text-based outputs or generated content, we're also beginning to see systems that are becoming more widely available that are able to sort of translate text-based prompts into images. Sort of multimodal generative AI is oftentimes how it's referred to. And so there have been some interesting studies emerging around what happens when we ask an artificial intelligence system or large language model system to translate text into images. And here's an interesting example from Bloomberg, confirmed by some academic researchers as well. And so what you'll see here, right, is some really interesting patterns. So all of the images that you'll see in these next 2 or 3 slides are completely auto-generated. They're computer-generated. These people do not exist. The system was able to generate them based on the prompt. So in this case, the prompt was for a housekeeper. And there are 2 things that you'll notice here, and you'll see similar patterns in some of the other prompts that I'll share with you here in a moment. One, very sharp gender distribution here, right? Overwhelmingly female. And also, right, race and ethnicity markers as well. And so sort of raising questions about the ways in which this prompt and large language models are making certain kinds of predictions, making certain kinds of analysis based on words, and then how that gets generated into visual or other kinds of media content. In this case, right, the prompt was for generating images of an engineer. And again, here you'll see a very sharp sort of gender distribution here, heavily male in terms of the images that were auto-generated. And also what Bloomberg did in this study was to do analysis of skin tone, right, and to what degree, right, were lighter skinned people associated with higher status, higher paying professions versus darker skin complected people associated with lower status, lower income paying kinds of occupations. Here we see a similar kind of expression for CEOs. Here is one for social workers. And here is one for doctors. And then I think a final one here for drug dealer. And what this suggests, right, is that there's really interesting stakes associated with how we are beginning to understand the potential impacts of these systems and how they're understanding and in some ways reflecting back to us the world that we as humans have generated. And so we'll get into in a moment, right, what's sort of happening behind all of these systems and what are some of the factors, both technical and social factors, that contribute to these kinds of outcomes. Now, the question, why should we care, I think is really important and hopefully obvious to you at this point. And a question, right, that many of us in the Good Systems Grand Challenge are asking, and certainly other researchers around the world are asking, is when is it ethical to deploy these kinds of systems? It's one thing, right, to have an algorithm that can recommend movies or TV shows or documentaries that we might like or prefer via Netflix or some other kind of platform or channel. But what happens, right, when the stakes become increasingly higher and higher and higher, when in some cases, literally, lives are at stake? At what point, right, do we begin to understand, right, the sort of severity of the potential crises, and what are we doing as a society to protect against, right, the kinds of harmful sort of downstream impacts that these systems might have? And this is something that's certainly driving a lot of the questions that I ask in my research, and certainly a number of my colleagues in Good Systems and beyond. For those of you who may be interested in sort of exploring some of these issues further, Here is a series of academic studies and literature that have sort of delved into these issues in very deep and significant ways, and I highly recommend a number of these as well as other studies, which I'm sure we can share with you beyond this particular lecture. Question number 2, what factors contribute to bias and systemic inequities in artificial intelligence? Again, as I noted earlier, what's really interesting about AI, right, is that even though the sort of technical proficiency at which we're seeing these systems perform, the reality is, right, is that they are still built, designed, engineered, and deployed by humans. And so in that sense, right, we exercise a certain degree of agency, or at least potentially exercise a certain degree of agency over how these systems come to be, and more importantly, how they're used in society. But there are a number of different studies, a number of different research efforts that are beginning to sort of identify, what are some of those factors that lead to these sort of bias and disparate outcomes, some of these systemic inequities that I've referenced here in this early part of the talk. One place to start, right, might be looking at just the life cycle itself, right? How are AI systems developed? They go through, right, a fairly sort of rigorous process, and here are some of the primary components associated with that process. So for example, and the point here, right, is that at any point along this life cycle of AI development, bias, oftentimes implicit, which may have downstream discriminatory impacts, can occur. So for instance, right, oftentimes, right, a problem or a question is asked, right? Something is being attempted to be solved via a model or computational system. So we might ask ourselves, what or even whose problem, right, is being solved as a result of developing and deploying a particular AI system. A lot of information, a lot of research has focused on the data component here. And we know, for example, right, that when data sets aren't representative of the broader population, it severely compromises the ability of that model to perform adequately when it's then used to make assessments, evaluations, or some other kind of analyses of populations that have not been adequately represented in the data set itself. And so this sort of speaks to, right, one of the reasons why people oftentimes refer to as bad data in, bad outputs generated as a result. But we also know, right, that humans are oftentimes involved in the data collection and processing experience. So for example, humans are not only selecting data sets, but they're oftentimes curating data, they're oftentimes annotating and labeling data, and the kinds of biases and assumptions that we make about the world and how we sort of express our view of the world via the data that we use can oftentimes, right, have these sort of bias and downstream impacts. I like to think, for example, right, or like to say, for example, that data is an artifact of the human experience and how we assess and experience the world around us. The model, right, what are we optimizing or asking the model to do? What task are we assigning the model, and to what degree, right, might that sort of lead to certain disparate impacts or outcomes that we should be mindful of and aware of? And then finally, deployment and monitoring. And to what extent is a model, once it's released in the world, to what extent, right, is it being measured, assessed, and evaluated for potential sort of disparate and biased kinds of impacts? And so the point being here, right, is that as we think about this life cycle, as we think about the development of AI, bias can happen anywhere along these dimensions, and oftentimes, right, is a multi-dimensional problem as opposed to one that's just simply bad data. There are other things happening too that compromise the ability of these models to perform in a way that mitigates, reduces bias and the sort of disparate, discriminatory impacts that can oftentimes occur. This is an interesting book and an interesting observation. Brian Christian isn't the only one who's made it, but it's this idea of the alignment problem. And if you follow the conversation taking place in artificial intelligence today, if you follow the conversation taking place in big tech, if you follow the conversation taking place in the machine learning and engineering community, you're oftentimes likely hearing references to the alignment problem. And what is the alignment problem? Well, more specifically, the alignment problem is a reference to, on the one hand, right, let's say we design an AI system in this, as we mentioned earlier, to be able to predict a certain outcome, to predict crime or to predict a health condition. And so our sentiments, or what we want the model to do, are fairly, not malicious, no ill intent associated with them. But then what those models actually do and how they perform can behave in such a way, right, that are sort of misaligned with what our values might be. Presumably, right, our values are not to exercise bias in our high stakes institutions. Presumably, our values are not to cause harm to certain segments of the population or to discriminate against women when we're trying to make decisions about who we hire. And so it's this idea of the disconnect between what we want our models to do sort of in theory or in principle and what they actually do in practice, and sort of the disconnect and the sort of misalignment there. In other words, how do we engineer and build systems that actually do what we want them to do and that are consistent with our values as humans? In terms of the compass model that I alluded to earlier, there are a number of factors that help to explain why it was making certain kinds of discriminatory decisions and why it was oftentimes misreading and misassessing African Americans compared to their white counterparts. A lot of this has to do, for example, if you think about, right, crime data in this country, police data in this country, who's most likely to be arrested, which communities are most likely to be surveilled and policed in a very aggressive way. All of these things, right, were sort of informing, these sort of historical biases were sort of informing the model in ways that perhaps practitioners simply were not aware of. Using things like zip code, which are oftentimes a proxy for race or a proxy for class or economic status, and therefore penalizing people in circumstances like that. And then, as we'll talk about here in a moment, just sort of general sort of measurement bias, right? Sort of using arrest as a proxy for crime. Again, when certain populations are more subjected to and much more likely to be arrested, therefore disproportionately associating them with this proxy of being a criminal or criminally minded. And so in this sense, right, there were just a host of biases sort of embedded in the model, including, right, this notion of measurement bias. And even the model, right, was sort of, collecting information about a person's parents, right? Had your parents ever been arrested? Or your friends or neighbors, had they ever been arrested? So making predictions not only about you, but the kinds of people that you may be connected to, the kinds of people that you may live nearby. And if those people certainly fall prey to some of these kinds of conditions, sort of evaluating you in that way as well. So there were a host of factors that contributed to why this model was leading to problematic outputs that raised a lot of concerns. In terms of the Amazon hiring algorithm, here's a really interesting quote from one of the reports about what was learned, from the failure of the system. Amazon's system was essentially taught itself, according to some of the research, that male candidates were much more preferable to their female counterparts. So, for example, it would penalize resumes that included the word women's, as in women's chess club captain, and it downgraded graduates to all women's colleges. And so, like a lot of these, models and algorithms that are looking for, key signals, which may be represented, for example, in certain words that become a signal or a representation of a particular kind of desired outcome or a preferred, kind of candidate in this case. And so this is a really interesting example of how the model was essentially teaching itself, right, to basically replicate the kinds of gendered hiring practices that Amazon historically had been very much engaged with. This is interesting. I'm going to come back to this question of the alignment problem for a second here. Here is a visual from 2014. And Google was one of the first of the big tech companies to release its workforce statistics. After resisting Google, Amazon, Microsoft, Apple, all of the big tech firms for a long period of time refused to divulge or release their workforce data. And finally, they relented. Google was the first. You'll notice two things here very obviously and very clearly. One, the sort of significant gender skew in terms of the Google workforce in 2014, 70% men compared to 30% women, and then looking at the racial and ethnic composition of its workforce, decisively white and to some degree Asian as well. I show you this, right, because in some ways, I think the conversation around the alignment problem is missing something really important here. And the question that I want to pose to you is, to what degree, when we think about these systems, is this an alignment problem or a problem of systemic bias? And I go back to the Amazon hiring algorithm just as an example here. The algorithm was actually performing in a way that was consistent with the way Amazon hired. So it wasn't misaligned with Amazon's hiring practices. It was quite consistent with the ways in which Amazon had hired and had figured out a way to sort of identify the signals that matched and were consistent with that. And so this suggests, right, that we're oftentimes training models, right, in ways that are consistent with our systemic biases, our systemic inequities. And this perhaps is an alignment problem, but perhaps more broadly speaking, is a problem around the ways in which systemic bias manifests itself in the ways in which we design, engineer, and deploy these systems. One of the reasons noted for the high false match rate for certain segments of the population when it comes to facial recognition system is quite frankly, right, a relatively simple fact, and that is the degree to which these models were not trained sufficiently with people of darker skin hue, with women in particular, women of color. And so in this sense, right, there was just the models that were trained and their capacity to recognize simply did not have a representative sample that allowed them to perform adequately and equally across diverse population segments. And so again, suggesting that there are a number of different factors, a number of different reasons that help to explain, why these systems oftentimes end up behaving in ways that are inconsistent, right, with our values for protecting certain, protected classes, or simply, not operating in ways that reproduce systemic kinds of biases. And then even here, right, in terms of large language models, similarly, the ways in which, these models are making, clinical decisions are based in part, right, on the ways in which it's picking up on very specific signals that may be associated, right, with certain demographic segments within the population. And so in this regard, right, sort of thinking about both the sort of technical but also social aspects that are associated with why these models oftentimes perform in ways that are deeply problematic. Some of you may be familiar with this analogy. Oftentimes, algorithmic models, are described as black boxes. In other words, right, they are sort of technical processes that we simply don't have access to. There's no transparency in terms of how a model is going about making its decision. We know that information or data is going into a model. We know that some kind of model operation is in effect, and we know that some kind of output, right, is generated. But the question is, right, the lack of transparency, the high degree of secrecy in terms of what's happening within the context of that black box, within the context of that model, has become increasingly problematic, leading some to sort of use the term the black box society. And what do they mean by the black box society? In some respects, right, this is a reference to the extent to which algorithms are increasingly being used, increasingly being deployed in these sort of high stakes decision-making domains: criminal justice, education, employment and hiring, the clinical and health space. And the idea, right, is that these decision-making mechanisms, right, that could in some cases literally have life and death consequences, are largely hidden from public view, comment, and scrutiny. We have no idea, right, how these systems are making their decisions. And in fact, what we're learning, right, as machine learning models become more complex and become more independent, even those who create them aren't oftentimes aware or understand how outputs are being generated, raising really interesting questions and concerns about why in the world are we deploying these systems in certain contexts when we have no full understanding of how they may be functioning and how they may be making decisions. And so what you're hearing more and more about, right, is the need for greater transparency. But the argument here, right, is that this black box society exercises a kind of invisible power, influence, and authority over society, which, if we're not careful, right, can be lead to very dangerous downstream impacts and outcomes. And so there's an increasing call, right, to basically sort of reveal what's happening kind of under the hood or in this black box, to sort of avoid this sort of black box society paradigm that we see ourselves kind of gravitating towards. And I'll just mention this real quickly and sort of wrap up here. This is a really interesting study. I think this was published about a year or so ago. And this is a team of researchers who were basically studying medical images. And they were designing models to be able to see if you removed any sort of demographic features related to race, for example, any sort of known signals related to race, could the model still predict, without any kind of explicit reference to race, could it predict the racial or ethnic identity of the person represented in these medical images? And the models were able to perform quite highly, right, in terms of consistently being able to identify race and ethnicity, even when those explicit markers weren't available to the model. They went even further and began to start experimenting. If you degraded the image, and they were trying to figure out other ways, other things that the model might be picking up on. Maybe certain disease, prevalences, certain racial ethnic segments are more prone to certain diseases than others. Well, if you could account for that, if you could account for anatomy, if you could account for bone density, a number of different things, geography, a number of different things that they were trying to account for, and when you removed all of those things from the model, it was still able to predict race. And the takeaway here is that what we're beginning to learn is that we are building models that are able to detect signals that we as humans simply can't identify, recognize, or certainly understand. And so this sort of superhuman capacity or uberhuman capacity of machines, in this case, to be able to read or detect race, even when researchers are working tirelessly to try to prevent the model from doing that. And it suggests, right, that these models are likely performing similarly in other domains and in other instances, and we simply are not aware of it. So there are a number of different kinds of biases in the article that was assigned for you today. There are a number of different indications of how bias is sort of manifest or demonstrated in the context of AI. I'll just mention one here, measurement bias, and that is, the degree to which there's a lack of accuracy of measurement across various populations. And so, for example, the COMPAS risk assessment algorithm that I mentioned earlier, if, for example, it's associating arrest with crime, and if African Americans are disproportionately more likely to be arrested than their white counterparts, then that is an example of measurement bias, right? In terms of how you are measuring in a way that sort of is disproportionately likely to sort of have a disparate impact on one segment of the population via another segment of the population. And then real finally, like I said, like I mentioned earlier, there's an entire industry that's beginning to emerge, both within academia and outside of academia, to develop techniques, to develop practices and protocols that are designed to sort of mitigate, that is to say, to reduce the likelihood of these models performing in this way. There are any number of sort of fairness models that are being developed by machine learning experts, things like parity metrics, things like race neutral or race aware or race unaware algorithms. The conversation around fairness in machine learning in AI is very robust. Oftentimes, I think a little bit constrained in terms of how it's understanding the sociology associated with fairness and equity, but that's another conversation perhaps that we can have. Here is a reference to another study, right, looking at the ways in which developers are identifying mechanisms tools that might allow them to better design systems that, again, reduce or mitigate the likelihood of bias and discrimination happening within the systems that they build. And I mentioned earlier, right, this idea of the black box society. And what that has yielded is a conversation around what some refer to as algorithmic transparency. And that is the need to sort of render what's happening inside a computational model more transparent, more visible, therefore more open to scrutiny and assessment to a broader segment of the population. So algorithmic transparency is something that we're seeing more and more of a call for. A lot of concerns, of course, associated with that. Companies might say, hey, this is proprietary, this is trademark information. We shouldn't be forced to reveal that. But if these models are being used to make these kinds of high-stakes decisions, what are the trade-offs here as a society that we're willing to make? Another sort of technique is more AI that's explainable. In other words, if I'm refused a loan for a mortgage, for example, or what we found in the case of COMPAS, defendants who were being denied bail or who were being given sentences that seemed to be extreme compared to the crimes that they actually committed, there was a call for saying, hey, they should have explained to them how this decision was made. And so in other words, right, making these systems more explainable, more interpretable, more understandable to the broader public is something that we're seeing a greater call for. Other things like around sort of auditing and monitoring algorithms, there are whole new protocols and techniques developed in that particular venue. This idea of human in the loop, right? That no machine algorithm in the healthcare space, in the criminal justice space, or elsewhere should be deployed without some kind of human interference, human interpretation, human decision making. In other words, right, we should not be allowing these machines to make the decisions. Perhaps they can augment the decision that we make, but we should not be giving them the utter authority to make these sort of high stakes decisions. Bringing in greater diversity, more domain expertise. I think we've come to recognize that it's no longer suitable or appropriate only to have engineers or computer scientists in the room when these systems are being made, but that you need ethicists, you need social scientists, you need humanists, you need a variety of kind of expertise, sort of informing and understanding the broader implications of these systems. And then finally, just greater AI literacy for the broader public is something that's being called for as a way to address these problems. Thank you, and we'll now go to the quiz.
welcome back to the Q&A session. And let me just remind those of you who are here in the studio that you can ask questions directly while you're in here. Please feel free to do so. I see one right now.
Yeah. So you mentioned the question of whether these biases and systemic inequities originate from the alignment problem or a problem of systemic bias. Would explainable AI be able to uncover the weight that each factor plays in these algorithms, and if so, how?
Yeah, that's a good question. I think mainly, the whole movement towards, or the call, right, to make these systems more explainable is in part an effort to make them just more accountable to the public, and the public who's, subject to the sort of decision-making authority that we assign to these systems. And so that could be a response that could be technical, or it could be less technical, and therefore maybe depending upon the direction in which the explanation was delivered, it might be able to make some type of evaluation on whether or not this system was in fact misaligned, right, with the perceived values of those who originated or sort of formulated and developed the system itself. Or, and I think the point that I was trying to make is that what's oftentimes interpreted as an alignment problem really isn't an alignment problem, right? It's a manifestation of the sort of systemic inequities that are deeply embedded in our society. And what's becoming more clear to me, and I think others, is that what we're doing a really good job of is sort of training these models to sort of replicate these sort of systemic biases in a way that's automated and at scale. And so as a result of that, sort of understanding, how do we, create a process that sort of understands, to your point, right, when there's misalignment and when perhaps there's something else happening, right, that's more systemically, oriented.
All right. Online, we've got some questions. Are the new standards for AI safety and security issued by the president enough to protect the public from biases inside those black boxes?
That's a good question. I know that the Biden administration has assembled different task force and committees to address some of these problems. There's always the issue of developing policies, but then developing mechanisms and developing, operations and protocols that can actually, deliver and execute, right, on some of these ideas. And I think that's the challenge, right, that we're still sort of waiting to see. And of course, I think, what we and more people around the world are understanding is that what it's likely going to require is more legislative and regulatory interventions, and we all know how slow we've been to arrive at those kinds of outcomes.
Well, along those lines, are there any AI systems whose sole goal is to identify bias?
Yes, and I didn't talk about this just for the time constraints. But AI is being used in a variety of ways, and in some cases, AI is being used to actually identify and assess, bias in many different domains. Let me give you one specific example. I think at least a couple of weeks ago, you had a presentation related to natural language processing, or NLP, and talking about some of the different technical aspects of large language models and how that system works. We've seen studies, and in fact, we are now trying to gear up to do studies ourselves that are deploying NLP to actually detect and study bias across many different domains. And one example, for instance, is in the healthcare space, where I'm beginning to spend more and more of my interest in time in terms of health equity. Taking, for example, like clinical notes, right? Notes that a doctor or notes that a nurse or nurse practitioner sort of generates, sort of documenting their interactions with the patient, what they're seeing, how treatment is going, et cetera, et cetera, et cetera. researchers are now using, for example, AI or natural language processing specifically to identify sentiments and the use of language, and training models to be able to predict based on certain sentiments, based on certain linguistic markers, predicting whether or not that patient is male or female, predicting whether or not that patient is white or black, for example. So language that tends to be stigmatizing of a patient is oftentimes more highly associated with being a black patient or a Latinx patient. And so I think those are examples of how we are perhaps using AI to better understand bias. And what I like about that model, right, and we've had some conversations with healthcare professionals, is how you might actually use an assessment or an analysis like that to help train them on how to begin to start reducing or being much more aware of how they're encoding bias in their medical notes.
Right. So let's just wrap up with one more question, again, along those lines. It appears that AI can teach us about bias in our society and thus is a useful social tool for that reason. Sounds like you're basically pointing that out here.
Yeah. I mean, if all of the examples that I gave you, right, and we can, I think it certainly can work both ways, right? On the one hand, we're seeing how these systems are replicating at scale and in a very automated fashion the kinds of historical and discriminatory biases that we as humans have practiced. But it's also, right, as an opportunity to sort of learn at scale, right, how these things get demonstrated or expressed in these various ways. And so it then compels us as humans to sort of engineer not only technical systems, but social systems too, right, in ways that sort of address that. And a lot of what we talk about, right, in good systems and beyond is understanding these systems not only as technical systems, but social systems. So we oftentimes use the word socio-technical systems. So thinking about how we as humans can sort of deploy our own expertise and ability to detect the sort of weaknesses in these systems and sort of correct for that.
Right. Well, thank you, Craig. And thank all of you for week 11 here. Next week, we will continue talking about social implications as we're doing now. We'll have Sherry Greenberg from the LBJ School to talk about impacts on workplace and economics. Thank you all.